Okay, so for this problem, we have to draw the shear moment diagram for the simply supported beam but under the trapezoid load. So the first step is trying to take the whole beam as a FBD so that we can find out the reaction force at A and B. A is a roller support, so only provide Y support. B is a pin support, so we had Bx and By. So now what we have to do is try to simplify the trapezoid load. So how we are going to simplify the trapezoid load is trying to divide the shape that we are familiar with. So we can try to divide them to a rectangle and triangle. So we can see for the rectangle, the total load here will be acting on the center of rectangle, and the total load will be the magnitude, which is 2 multiply the whole length. And again, it's acting in the center of rectangle, so which means the distance to A will be 9 feet. So now, don't forget the triangle load. We haven't simplified. So the centroid for the triangle load will be 2/3 from the tip. So which means the distance will be 18 multiplied 2/3, 12 feet. So what is the magnitude for this simplified triangle distributed load? Will be the area of triangle. 1/12, the base is 18, and the height of the triangle will be 6 minus 2. So totally we had 36 pips going down. So now, after we get everything ready for the load and dimension, which means we can try to solve the reaction force. So let's try to summarize the force moment around A going counterclockwise will be positive. So which means we are going to have rectangle load multiply the distance 9 feet. However, this is a clockwise rotation, so the whole thing will be negative. So we move to another load. Triangle. Distributed load. And the distance to the A location will be 12 feet. Always remember, we had a lot of turn. Keep it in your mind. This is a force. This is a distance. And then Bx will passing through A, so which means there's no moment. So the only thing we have will be By multiply the whole length, 18 feet. So in this equation, you can see we only had one unknown force, so which means we can solve By, which will be 42 kips. It's positive, which means our assumption was correct. It will go up. And now, if we try to summarize the force in the Y direction, we should be able to solve the AY plus BY. We already solved the BY, 42. We had rectangle and triangle load going down. So we can solve the AY. 30 kips. So before you move on, try to write the shear moment function. I highly recommend you to do one step. Try to check all the reaction force you calculate here is going to be correct or not. So what we are going to do, let's try to summarize moment around B location by using the AY from this step. So let's take a look. We are going to have AY 30 multiply 18. And now the green, which is a triangle load, create moment around B will be positive 1/2 6 minus 2. So the distance from this load to B will be 18 minus 12, 6 feet. And we do the same thing for the rectangle. So now it's time to punch your calculator. If your final answer equals to 0, so which means all the calculation is okay, you can move on to the next step.